Hello and welcome back. If you follow the channel, you know that we recently restored an awesome vacuum tube oscilloscope from the 1950s from the French company Metrix. An AI review of 300 episodes of Mr. Carlson told me to recap it, which surprisingly turned out to be a bit unnecessary for the electrolytics, but well advised for the paper caps. We also replaced the higher value carbon resistors, all the ones above 100K. They had drifted higher, a common aging behavior of vintage carbon resistors. But the lower value resistors spot checked perfectly on target, so we left them alone. When we repaired the scope, it mostly worked, except for a vexing vertical axis instability. We eventually traced it down, to our surprise, to a bad lower value carbon resistor. A lowly 20K resistor had upgraded itself into a potent 843 kiloohms resistor. Everything went back to normal after we changed it. But I'm curious, it's in my name, so I wanted to know why it failed. From the outside, it looked fresh and delicious, with no visible signs of damage. So I consulted with Tube Time, who has published a bestseller picture book about slicing into electronic components. He told me to simply sand it down by hand. Nothing fancy, 200 grit to start with, then progressively finer to taste until I liked the surface finish. So of course I was curious on how a resistor could fail and become infinite resistance with no apparent problems outside. So following the advice of my good friend Tube Time, I polished it, sanded it in half, and that's what we find. And it's not what we expected to find, actually. Well, I did a good job sanding. This is quite beautiful, but what does this all mean? So I was expecting something like what Eric had seen while looking at vintage carbon resistors, a simple structure with two leads at each end and a blob of dark carbon-loaded material, encased in a yellow-brown external resin coating. But I got this instead, not the same at all. Are French resistors made out of cheese and sausage? Maybe not. The cheesy-looking outside is the resin envelope, and there is some kind of glassy-looking rod in the middle. It's not entirely clear what's inside that rod. I can see some black powder, which I assume is carbon, but also some silverish looking material. It's not homogeneous at all. On either end of the rod are somewhat involved contact structures with some copper obviously, but there is more going on. Zooming in, there is something going on in the middle of the tube. Sliding to the end contact at the left, we can see a copper plate, but also a concerning crack in what appears to be a solder joint between the copper and the tube. Maybe that's where the fault is, a crack that developed at the solder end? It was a bit inconclusive, so I decided to sand further to see if I could get further into the center glassy portion. So not having come to an exact conclusion and being intrigued by what's in the middle, I'm going to sand further. I think we have shattered a glass envelope or something. Aha, success! This was actually a hollow tube in the middle. Let's go under the microscope for further inspection. What do you think, Eric? I see a big empty void in the middle.
I got some theories about it. So, one possibility is that this is actually on purpose, and you have a tube that's got a resistive coating on the inside, and then to set the resistance, you take those two bits of metal and you plunge them different distances into the tube. So you adjust it to the right distance, and then you crimp, and then you put your contacts on the outside and you encapsulate it, and then you're done. So
yeah, that could be that. But then where was the failure from? I think Eric is onto something. The two sides are conductive plungers making contact to the resistive tube via the powder I had seen, which has now escaped. It's unclear if the failure is in the tube or the interface with the plungers or at one of the end contacts. So we appear to have repaired the resistor somewhat. If I measure at the ends, it's 100 kilo ohm something. Oh, it's moving a lot. 111 measured from here. And it doesn't change, 111. So the resistor is indeed in the middle. It's going to be hard without my hands being all over it. Yes, they are all over it. But let me try to show you. Okay, I can do it like this and like that. That's connected. So the plunger is connected. Same here. Well, it's 0 ohm. And the resistor is, I need to be there, in between the opening in the middle. So I subscribe to tube time theory that the tube in the middle is the resistor, and then you plunge your ends as far in as you need. Oh, now it's 300K. So probably what failed is the contact of the plunger to the outer sheath. Our plungers didn't make good contact with the coated glass tube. Interesting. Anyhow, it's dead. So since the plungers make solid contact with the end wires, the failure appears to be between the plungers and the resistive tube, and we kind of partially repaired it just by wiggling these during our sanding. But it is sure a very pretty and complicated resistor construction. I hope it makes it in Eric's next book. In the meantime, see you in the next episode.